Hi everyone, I'm Piette. I'm a postdoc researcher from the Maastricht University. I'm working mainly in game artificial intelligence, so I'm not an historian or an archaeology guy. This is just a pleasure for me to speak for the first time about this new field, the digital archaeoludology. Games are ubiquitous. Almost everyone plays games. If you look at any part of the world, in the past, in the present, and I'm sure also in the future, even on this building, I see a lot of people playing in their smartphone with a lot of games. And of course, all the cultures have some own games. So you can see the games is a historical context like a cultural heritage, an insight into the cultural past. Sometimes a game is also proof of cultural contact between some people, between some civilization. But unfortunately, we don't know much about things about ancient games. Of course, we find a lot of archaeological evidence, some boards, some pieces. For example, you have here the main game is an ancient game from Egypt. It's played on a spiral board. He used some different kind of pieces, some smaller, some bigger, but we are not sure of the rules of that game because we never find the record of rules. And that thing can be explained because by tradition, in a lot of cultures, the rules were transferred between two generations only by oral. So when we try to rebuild the rules of a game, we have to work only with our evidence we find. And consequently, for all the ancient games, we have a huge variety of possible rule sets, and maybe the original rule set is are lost. This is an example of a possible cultural contact. In India, we know that game, Piette, and in ancient Mexico, another game called Piette. If you look, the board is really similar. It's a cross board with some special cross at each extremity. This is just a picture, but if you look, the real board, this is really similar, but the rules are different. According to some different research, some study on these two games, the first one explains this is just an evidence of an early contact between India and ancient Mexico. In another study of Erasmus, he says this is just a coincidence. And the last one say we assume this is a coincidence is the last word result. Unfortunately, we are not sure if that game is a proof or not of cultural contact between these two people. And on all that study, we don't find any mathematical models or any further tools to prove that. For another example, really famous one, Senet. Senet is the oldest game found in all the history from ancient Egypt, from 3100 before Christ. Of course, we found a lot of sense in a different time, different place, but again, no rules. So one question, is it a game or something else for religion or for tradition or for something like that? If you look the hieroglyphic art, you see two players playing to that games with two colors for the pieces and some different starting position. On the board, there are also some different symbols on it, but we are not sure if this is the entry or exit points for that game. And for all the study for this kind of study, we have a dozen of reconstruction, and again, no mathematical models or no software tools to prove if one of them is better or not. So the goal of the digital archaeology, a new field using a lot of different benefits from a lot of other fields like history, mathematics, cultural study, archaeology, computer science, and artificial intelligence, is to create a link between some traditional game study and some modern game AI techniques. In the traditional game studies, we find a lot of historical analysis, but only some few mathematical analysis. In the game AI study, since now some years, we have a lot of really great results. I'm sure you know AlphaGo from Google, for example. We have a lot of really good artificial intelligence on it, and it's possible to apply the same algorithm to some other field. Unfortunately, until now, this field, the game AI, has a little interest in historical context. So the goal of the digital archaeology is to bridge this gap. This project is called Digital Udem Project. It's possible thanks to an ERC from the Union European of 2 million euros for 5 years. It was launched in the Maastricht University at the beginning of the last year. We have currently a team of 5 people. Browne is the principal investigator of this project, create it and find the grant. I'm the second in charge of the project, the game system engineer, mainly working on our general game system. You will see that in some slide. Matthew works mainly on the data mining and visualization. Denis Summers is our PhD working mainly on feature learnings to make a link between modern games and ancient games. Walter Quist joined the team in July, is our new cultural and historical expert, but we work also with a lot of different experts on ancient game today. The objective of this project is the first objective of this project is to model the full range of traditional strategy games throughout recorded human history. With that, as you can see on the two examples at the beginning of this presentation, we would like to reconstruct the missing information with an improved rigor, so using mathematical model and a new software provided by our project. And another goal is to map the spread of games for each game, of course, associated with the mathematical ID behind that throughout history. So to sum up, the goal of this project is to improve our understanding of the development of game in using modern AI techniques. So we define a new field with this ID, like that. The digital archaeology is to use the modern computational techniques to improve our understanding of the development of traditional games. The methodology to do that, first one, we have to identify the 1,000 most important traditional strategy games. To do that, of course, we refer to a lot of different books or publications, but we work also with a lot of different historical people working on the study of some ancient games, mainly from the game study community, if you know that. With this 1,000 most game, we would like to model them digitally, thanks to Ludem. I will explain what is Ludem in some slide. And we would like to look at them historically and culturally from all the data we can find in some source. With all that data and this modelization, we can find some relationship between the games and also the different components of the games, so the Ludem, in using data mining and phylogenetics. And from our results we can find with our project, we would like some feedback into our reconstruction. Of course, this is really important to understand. We don't deal with certainty for any kind of result we can find because we cannot be sure of our result, but we can associate it to any kind of result, a probabilistic estimate with some different criteria. The scope of this project is focused mainly on a traditional game strategy. We define traditional like a game with no inventor or no proprietary owner, and strategy, a game with mental scale. So, for example, board game, tiling game, or card games. We are interested by game between 3,100 before Christ, so the date estimate for Sonnet, the oldest game, to almost the year 1,900. We speak about the 1,000 most different example, but we can also working with some variants or some reconstruction building by our project. And we estimate we have to evaluate something like 1 million rule sets. Of course, this is just impossible for human, or maybe with a big team for 1 century, so we don't want that. But with artificial intelligence and with computer science, that task is really possible. So, Ludem is a game name. It's a unit of game-related information. You can see that like a building blocks for games. If you want to make an analogy, a Ludem is like the DNA for games. A Ludem encapsulates the key concept of a game, so a Ludem can encapsulate any mathematical ID behind a game. David Piette, an expert in game study analysis, in 2007, wrote in this book, a Ludem is an element of play comparable to but distinct from a game component or an instrument of play. This is a really good definition. In all the projects, we follow the definition to define our Ludem. So consequently, with the definition in mind, if we can do that with computer science, the project can model any aspect of a game if this aspect can be modeled mathematically. For the project, we use Java. Java is a programming language, but it's also possible with some others, of course. And we can model any equipment or walls. So to make an example, you have here an example of a Ludem. So tiling square is to define a board game tiling by square. Size 3 is to define a board of size 3. And for example, you can define a board like that. So this is a square board tiling by square of size 3. That kind of board can be used to define a game. You have an example here directly in game description. Tic-tac-toe, everyone knows tic-tac-toe. You have two players, white and black, the bound defined before, and your only move is to move one of few pieces on any empty state. And you win the game if you make a linear 3. So this is how we can define games with rhythm. Thanks to that, our game description can be are just a text file using some symbolic expression. With that, we can define a rhythm tree to define the rules of a game. Of course, conform to our grammar, but the grammar is generated automatically by our system. So, for example, here you have possible games. We are not sure in order to if it's a game or not, called Wound Mirrors. It follow almost the same rules of a game, a very famous game called Swim Maurice. Maybe you know that. It's possible to define all the rules of that game just with this data. And we can add also to that file some metadata, anything we want, anything we know about that game, to put that in a database to create a model. So we use this game description because it provides a lot of benefits. First one, this is very simple to define new games, just with some minutes or seconds in writing directly the rules with them. This is really powerful. Our approach can model the full range of games. Really compact. The file size are smaller than a QR code, so really small, and also possible thanks to that to provide in the future our application to smartphone and using some really small file. This is comprehensible. You can understand the rules directly within the rhythm, but it's also possible thanks to many algorithms to translate the rhythm directly in English. So of course anyone speaking English can read that. Really efficient because in game AI another field exists called general game playing. On that field it's possible to apply some artificial intelligence technicals to any games, but our system is really faster than that system. For example, for chess we are 10,000 times faster. This is covenant. We can easily manipulate or evolve a game. It's not too hard to get a new variant or reconstruction. And granular because the game is composed of different rhythms, so we can break down the game to understand if a game used or not a mathematical concept behind it. So this is the system. It's called Ludi. Ludi is a general game system. With it, it's possible to model, to play, to evaluate, optimize, or even generate any games. Anything is possible. On this system is mainly organized in two parts. The first one is a rhythm library. Each rhythm is associated with a mathematical ID, and a rhythm is just a class in Java. If you use many rhythms, you can create a rhythm tree, and a rhythm tree is a game. We can store that game in a database associated with historical data. With just this organization, we have almost all the system, and it's possible to realize anything you want with the games. So this is an example of our interface. We try to keep something clean, abstract, and informative, but also attractive because we want also to provide this system to game designer too. So we try to make the thing really usable and also practical for analysis. This is not currently available. It's almost finished for the first public release, but in July, if you are interested, you can go to that website, ludi.games, to get it. Of course, free, and it's possible to apply any kind of research you want on it, and of course to play if you want just to play. With our project, we have so many possibilities. For this talk, I'm focused only on the reconstruction and the creation of a spread of games. So for the reconstruction, as I said, we have some evidence, some partial rules or equipment, and we follow two main ideas to create some possible reconstruction. The first one is an historical authenticity, the second one, a game quality. For the historical authenticity, it's possible to rebuild a game automatically with a combination of rhythm in correlation with cultural and historical context of the proof of the evidence. For the game quality, we have a lot of different metrics to compute it. For example, we have a metrics to understand the longer of a strategy. If the strategy is really too small, for example, if you can win with only one move, this is not possible to define a game like that. But if the strategy is also really too big, something like 10,000 moves to win, of course, it's not a game for human, so it's also not possible. So we have a lot of metrics like that to compute it. And from that, with our system, we can build some plausible rules sets associated with a probabilistic confidence for each of them compute for our two metrics. So for example, in Slovakia, Some people find that board is 17 by 15 or 16. We are not exactly sure because it's almost is damaged. So we're sure this is not Go. Again, we don't know. Use two colors and one or two sides for the pieces. Again, not sure because some of them are bigger, some of them smaller. So we're not sure if it's just not perfect for this period or if you use two sides. And Ulrich Schraders, the curator of the Game Museum in Zurich, explained for human, this is just an impossible task to find the rules with just that. But maybe Ludi can turn this impossible task to a difficult one. So according to him, it's possible. And we try to work on it. To do that, our approach is to model everything we know directly in them. So we have here in green, blue, and red, everything we know possibly defined. And you know also everything we don't know. So we don't know the starting rules, the playing rules, as the ending rules for that game. We can associate with everything we know some combination of freedom from similar period, region, or culture. And we can maximize the historical authenticity and the game quality. From that, we compute some different playable rule sets with a confidence estimate. So this is one side of the project. The other side is the game suite of the games. To do that, we are in collaboration with another team in Madrid, working mainly on political maps with a software created by them called Archaeology. They create mathematical maps between 3000 before Christ to today for almost 2000 civilizations. And they use a database with political boundaries, historical sites, historical events, and historical routes. And they provide some results. First one, a cultural location. With GPS coordinate and years, they can find the dominant civilization at one point and one time. They provide also some historical rules from expedition rules, trade rules, military rules. And now, last result was a cultural distance. That thing is really important for us, yeah. In input, they put two GPS coordinates and some years, and in output, degrees of possible contact between different civilizations. It's also possible to do almost the same thing with the game ID, with a Ludem profile. Like I said, a game is composed here about Ludem, and it's also possible to trace the game from the occurrence. If we can do that, we can also trace the occurrence, the Ludem in the history and geographically, because we can break down a game into the component Ludem and correlate them with our occurrence to find the nearest and closest matches between them with associated to some probability. And from that, we can get something close to that. One Ludem can begin in one point in all the literature and the resource from the history. And we can correlate that with some trade routes, exploration routes, and military camps to know if this idea was in some different place at different time on the history. Of course, this is just two main ideas of the system of our project. If you want to know more, you can go to our website, ludem.eu, and if you are interested by the system, it will be free and available at this website. Thank you.